Hello everyone. Welcome. Welcome to the current installment of low-level object-oriented design of chess. Designing chess and expressing it in terms of objects, classes, the whole board game, the gaming, it is a unique challenge in itself. Reason being, how in a real life, a certain real life gaming situation can be converted into a object oriented system, that is a challenge in itself. And here we will uncover few things like when we will be designing this board and designing the various logics around the chess. We will get to know that how every small part of the system can actually be converted to uh, object oriented design, and that could then be extrapolated to like the whole design, like from single to multiple, from one to many relationship, how we create the whole system. That will be a very interesting exercise. So let's come back to what we are going to do here. So as you can see, like in my screen, that there is a board. This board is a 64 square board with 8 into 8 grid. So that is a standard chessboard. There are different kind of chessboards are available, but we are taking the standard international one. So yes, the idea is like we are going to have 64 square and in a 8 into 8 grid. Now here what exactly these things are, like R, N, B, Q, what exactly this thing signifies, right? So basically you can see here I have written this R, N, B, Q, K, P. This represent the different pieces. For example, Q here is basically the queen, K here is the king, the P are the pawn. So this the state that I'm representing over here, this is basically the very initial state of chessboard. Now, what are the basic requirement that we are going to address here? So, as you can see over here, it is written the system should support two online players for very obvious reason, and both players will make their moves one after another. So, at a same, so like at a time, there will be only a single player in the board. It is not that multiple people can use that system in the same time, and player can't cancel and roll back their moves. Very obvious again. And there is one interesting requirement is here, that the system should maintain a log of all the moves. It is basically like in the online game what happens sometimes, it let you trace back your, for educational purpose, it let you trace back your whole moves so that you can watch your own thought process, like what has been happening over there. So uh, these two are again very generic requirement, like 8 pawns, 2 rooks, and 1 queen, 1 king, how each side will have their pieces. And of course it will be like, although I have marked it as green and blue here, but as you know, in the traditional chessboard it is black and white. So this game also will be having a finishing condition, of course. So this is the most interesting part of any gaming situation that we do. So in a other than the simple input output and the definite algorithmic movements, also they come to a end state, and it gives you output like who will be the winner. So this is also one of the interesting aspect of this design, like about the finish or ending the game. So without further ado, just let us take the whole let us try to explore how we can convert it into design. So as you can see this part, like R and P, all these things, so these things are basically the pieces. So when we are talking about these pieces like K, they are being in a box, right? So you can see there are total 64 boxes. So if I have to just visualize it, what exactly is happening is there is a box. That box is having this chess pieces or chess elements, we can say, and that box will again is being held by, there are multiple boxes, is being held by a board. And this board, so this whole thing is a board, of course, and using this board, what we are going to do is we are going to have we are going to conduct our game, and there will be two-person involved, like there will be one player from this side, and there will be another player from the other side. Like if I see from this side, there will be another, sorry, there will be another player from this side. So this is going to be player one, and yeah, sorry, this is going to be player one, and this is going to be player two, and they are going to make their moves in the board. So this is the very basic structure, so you can understand what will be the basic components of it. So of course if I have to use this have these players, so of course there will be a class called players. So I will create it separately in the Visual Studio for the actual standard coding, but I'm just writing it for the sake of understanding for the timing, that there will be a class of players, and then there will be like here, as you can see, the box is the smallest unit, and box is having the chess pieces or the chess element. So of course box will be another class, and other than box, like the chess pieces or chess elements, they will be another class. So this chess pieces will have different kind of types, like the types will be rook, knight, bishop, king, queen, and pawn. There will be six different type of the chess pieces. So we will take some enum out of it, like while we'll be doing the coding, we will take care of it. And other than that, there will be the whole board. So board will basically hold the structure. So how this box of 8 into 8 box it will hold. And other than that, like to control the whole thing, what we will do is we will have a game class. So for example, every single game will have a unique board, and in that board we will be able to backtrack every single thing. That is one of our requirement, and that board will have different boxes. The boxes will have these pieces of chess, or the elements of the chess, like king, queen, and everything. So this is on a very high level what the classes will be. And now we will try to figure out what will be the very basic elements of these classes. So let's start that exercise. Okay, so back in the Visual Studio, let's start with one by one all the classes that we have identified. Like there will be a player, and as from this diagram we can see, there will be box, there will be chess pieces, there will be board, and to control this board or to use this board, there will be a game at the top. So game will be basically the controlling function for every game. Like whenever a game is being initiated, suppose this is being integrated into a mobile application, suppose. So anytime the game is being initiated, what will happen is it will create a new board, and the state of the board will be maintained. There will be box, chess pieces, and whatnot. So let's start with the very basic. Yeah, so let's start a very basic class of players. So player will be, probably they will have some kind of a grid, for identification, and first name, last name. I think that will be more than enough. So like player ID. So this will be the very basic player class, because player by using player we will try to create the whole game around it. So this is the first class that we created. Now let's talk about little bit around the next important class that we discussed, that is this box. So for box, what we will do is we will try to see what are the, like, how we can convert it into a real world object. So what box will have is, so I will name it as board box. So board box will definitely have two things. One is the main position, or if we can look at this, and the obvious thing that will come is this is nothing but a 2D array, right? So if it is a 2D array, it will of course have a x and y, that is a row or column value, each of the boxes. So what we can do is we can try to express each of the boxes in terms of their row and the column value. So let's take like this. We will take row value, or simple row number will be a better row number, and we are going to have column number. So these are the two very basic thing to identify the board. And the next thing that we will need is what this board will consist is, the board is going to consist this pieces. So it will have the chess elements or the chess element pieces. So maybe we can create a new class for it, and for that, but before that, let's create that association directly. So suppose I'm writing something as a chest element, and chest and a piece. Okay, and Visual Studio is kind enough to give me, yeah, to give me the intelligence of creating a new class. So so that I don't forget about it, what I did was, like, I created it from here. Now the chess element, let's think what would be the kind of a chess element would be. So the chess element, if you can see over here, they are of this six different types, right? So this six different types of rook, knight, bishop, queen, king, and pawn. Now for that we can have a enum. So what we can do is public enum chess element type, and for that type we can just define different type, like it can be rook, it can be knight, king, queen, and pawn, and of course, yeah, bishop. That is something I forgot. So it will have rook, knight, king, queen, and pawn. So every chess element will be of it will have a type. So it will be like public, second, chess element type. I will name it as a piece type. Okay, so this is expressing that what is the particular type that um, element is, and then there will be properties like we can also put some kind of a ID against each of them, so that we know which one we are killing. For example, suppose there are 6 pawns, and one of them is getting killed. How do I identify them? Yeah, we can identify them probably using their XY coordinate, but we are going to need ID for them, ID or a name. So I will probably have some kind of a ID in terms of a GUID maybe. And after that, there will be a very interesting property that we need to create here. That is the um, movement of the allowed movement of that particular element. So when we are looking into this different one, so uh, pawn can only go to some XYZ places. It cannot go to all the places in the chess. Similarly, the rook can also go to a specified number of movement, like sometimes it can go to vertically, sometimes horizontally. This kind of some restrictive movements are there. It is not that pawn can directly jump from here to this place and kill another pawn, right? So uh, this kind of movement, we are going to have a uh, we are going to have a list of movement. So how we are going to express that is, what I'm thinking is, we will create a list, and that list will have a tuple of movement, like tuple of int and int. So this thing will basically create that x and y coordinate. So I will put it as an allowed movement. So this is nothing, just a key value pair sort of a thing. So instead of tuple, I can also have a key value pair, but key value pair doesn't hold very true meaning here. Rather, tuple would be better, because key value means that something is key, something is a value for that key. But over here, tuple means that it is kind of a pair, and it can be coordinate or anything. So over here, this allowed movement, here we are, what we are doing is, this is defining all the allowed movements. Okay, all the allowed movements in XY plane. So every element now, where are we standing? Every element that we are having, every element have a specified places to go. So we already have the box, and these chess pieces have a specified places to go. Then we have to denote that, suppose when the game is on, uh, what kind of type is that, like whether it is a black or white. So we can either take a enum, or there can be another very uh, like simple bool property we can set, like is white or is black. So we definitely could have taken enum, but like enum only for two values doesn't make, like it is a uh, white or black, there are only two conditions, so I am using bool over here. So also one more condition that can happen is, this particular chess element either can be alive in in our board, or it can get killed. So when the game is on, suppose when this this particular pawn, suppose in a certain scenario, maybe after 10 minutes of the game, it can kill another pawn. So those kind of, to handle those kind of scenarios, we will be to denote those kind of scenarios, we are going to have is killed property, so that we know that one like we will be removing this thing from our board the moment we find chess element is killed by some movement. So yeah, this is this is pretty much it. And also, this this can have interesting method as well, which we can write like something like a can move. but so can move will only take the will only take the current coordinate and the coordinates that I'm trying to move. If I'm able to if it is coming under the allowed movement, then only it will be moving. So what I can do is I can mark this can move, and what it will take is the int current row, int current column, and then it will take int target row and target column. So suppose there are certain yeah, sorry. Yeah. So suppose there are certain movement I have to create around this, and what I will do is by default I'm just returning false, but there will be a good amount of logic involved here. Like we will be checking whether we are going out of bound, whether we are going into any wrong direction, which is not part of the allowed movement and everything. So we are going to make use of this can move with that. So now that we have what are the elements we have is we have this players, we have this box, and we have our chess pieces ready. So now we are going to create the bigger one. So when I say bigger one, the whole board we are going to create now. So how the board will look, let's see. So in our board will definitely be uh, consist of the boxes. So what we are going to do is we are going to create a box property, something like there will be eight boxes here, and when we initialize it we will make it as a 8 into 8. Here I am not defining anything specific, so this boxes property will be like this, and then there will be a player property as well. So players property rather, so it will have a array of players. So again, public player, I will just create a array of players here. And one very important aspect will be this board will be we will always need the current enabled player of this board. For example, in case the player 0 is playing or the player 1 is playing, once he has marked his move, then he will be disabled unless player 2 makes his move or passes. Player 1 won't be enabled here. So let's do it in that way. So for that we will have a current enabled player. We are going to have this current enabled player, and as we were talking about, like this initializing the board is very important, because anytime uh, we are so yeah, sorry, this will be a 2D array, so I have to add a comma over here. So anytime we add our our board box, so boxes will be anytime we start our game, suppose it is part of a web platform. So anytime we press on the as a player we press on the new game, what will it should do is it should start this 8 into 8 board box, and then also there will be two player. So this player can be players again, there will be two players, right? So player 0 and 1 we will be initializing, and other than that there will be initialize the board. So when I'm initializing the board, um, what we will do is we are going to create a for loop. So for all the I for all the rows, we are going to create a default value around that. So what we are going to do is we are going to I'm just writing the pseudocode here. So for that box, of I comma j, and of course I will need another for loop. We are going to create a like a new board box, and in that board box we probably can pass whatever, like this board box is, again we are going to have a we should be having a constructor over here which will take the row number, column number, and the piece. So we should be having a constructor which will have this int row number, int column number, and chess element piece, which will be which we will be able to use here. So it will be ij and new chess element, something like this for not all the boxes, but as you know, in the like here for this two row and this two row, we are going to do that. So basically for all the rows and for all the columns and only the first two rows and the last two rows, we are going to fill it with the pawns and the rook, knights, bishop, etc. So this is on a very high level. How we are going to set up our board. Okay. So again, the chess element should also get one type. I'm not extending those things, but I think this is pretty self-explanatory that when we are initializing this chess element class, it should have all the piece type, uh, what exactly, whether it is a king or queen or bishop or the other types, what exactly will be the allowed movement for a given piece, and whether it is a white and is killed by default, it will be of course false at the initialization level. So all those things we need to set from here. Um, so now that we have our basic classes of board box, chess element, and the player, now we can just go to the game class. So how the game class would be? So game class, if you just remember, uh, there was one requirement was there that the game should maintain log of all the moves for both of the players. So any movement that happens across the board, okay, so that we need to store. So what we need to store over there is we should be storing in a certain state what is the movement for which for which element, what exactly the movement that has happened. So we can create a stack sort of a thing which will basically store the state of the board on every step. So it can be something like so different state of the board it should be able to store, like so that we can trace back. So board logs, we can name it like this. I will anyway put a getter setter, and we should also have the whole set of the current state of the boxes, so that in a current way, in case like w- the game needs to pass on, we always have something in our memory. So what will happen is public box. So in our board box, we are going to store all the board boxes over here. So this will be the current state of board boxes. And then we are going to have the current player. So as as you see, like here also we had a current enabled player. So probably we'll be able to use that part, the current enabled player. So we might not need the very current player, and but we will need a winner. So in terms of the public player, we will have a winner. So these are the very basic stuff we are going to have. Other than the constructor, now what a particular player will do when his turn comes, he will be serve a move. So the moment any move is being served, so we got to pass the player instance, we got to pass the target, we got to pass the current row, current column, and then also target row and target column. Now, if this particular movement is allowed, then what we are going to do is, like for example, we can very well write some sort of a private method, and with the logic of the uh, chess element types, we can try to find and of course, yeah, one more thing, like there will be the chess element. Yeah. So we will take a particular chess element. We need to move it from a current row to current row and column to a target row and column. So what we are going to have a method is movement allowed. So in that is movement allowed, we are going to pass all these things, like the player, the element, the current row. So let me just put them: current row, current column, target row and target column. So we have passed all these things, but this method is not there, so we will be generating this method. And this method, as you can probably understand from here, what this method will do is, I will just write the if condition here. I will make it a bool. Yeah. So what this method will do is, if that particular movement is at all allowed, then only it will change the state of the board. So uh, what it will do is, the board box in the current state of the boxes, it will make some changes, like around around the coordinates of various box. It will make the changes of the current state of the box, and what else it will do is, it will also do set next player. So it will also set the next player. So set next player will be again a very easy function to write. So what it will do is, like it will just do a private player. The set next player will get the given player, like whoever is playing right now, and using that, it will return, in case of it is player 0, it will return player 1, else it will return player 0 itself. What is this error I am getting? Oh, so what I need to do is I have to have a player instance returning. So what I didn't do was I haven't even created a board instance. So of course the game will require a board instance, right? So this particular board, I'm going to use this particular current game board, and in that particular game board, what I'm going to do is dot current enabled player equal to, if it is player 0, then I'm going to mark as a, yeah. So I just got a little confused, and because I'm completely doing it on the fly, and I could come up with this kind of a logic in case the player that I'm passing, it is player 0. So when I say player 0 means that if it is the first player, then we will set the current enabled player of that current game board equal to the second player. Otherwise, we will set it to the first player, like it will interchangeably do that. And in this way, what will happen is the current enabled player will be able to set it to the given player, and also we will be returning the current enabled player. So this set next player, whatever we have, uh, we should be able to pass the player over here. Even if we don't pass, like we can use the current enabled player of the main game. So anyway, we will try this is movement allowed, and then we can also have something like, once the movement is being done, we can make something like if game exit condition met. So before setting the next player, what we can do is we can try to see whether the game exit condition has met or not, and we can just have a boolean function for this. If it is meeting, then we will mark the winner as the whatever is the current player. So the current player will be the winner of this game. Otherwise, we will keep on setting the next player, and of course, else we can throw a invalid move exception or something like that. So feel free to have some creativity around this, like how we are going to handle if it is not like if it is not allowing the movement, we will just return, and for the time being we should just return or log something to the user that this particular movement is not allowed. So as you can see, this is basically pretty much it. Like the in the whole exercise, you must have noticed that what we have done is we have converted all the box, the whole board into small boxes of 8 into 8 size, and then what we have done is we have created the player, and using the main game, the board and the game class, we have defined this particular game. So the game will have constructor for sure. In that constructor, we are going to initialize the boards, and we are going to set the first player and all those stuffs we are going to do. Winner will definitely be null initially, and then what we'll have is it will have 4 very core methods. Any movement that we create, that will create as a server move, and whether that particular movement is allowed or not, and how we are going to define whether the move is allowed or not using this function. And probably like when we explore the logic way more internally, as you can see in the chess element, we already have this allowed movement or the can move. So any chess element type, we can check that whether this current row, yeah, by element id, any chess element id, we will be able to find that whether the current row, current column, and the target row, current column, that XYZ movement is valid or not. So this is pretty much it. I hope you get to understand this thing, and again, this is very important exercise in terms like how we can convert a real world a real world use case into our code or into our object oriented approach. So thank you very much. See you in the next video.